from the screen again. So can you see?
Yeah, it's better now.
Okay,
Yes,
so
please.
this is where the program call. This is where we call the contract or um, call contract. It's not contract, sorry, program on Solana. So what you do to call a program on Solana is first we need um, we need to create a transaction. If you guys remember what I said earlier, um, to communicate, every communication with the blockchain is via a transaction, and transactions are made up of at least one instruction. So this is a transaction I created, yeah, and this is an instruction. So now we'll see what the instruction is. Now, I'm using some predefined framework from the Solana playground that makes things somewhat easy. So from the playground, I get access to program. Yeah. So the program is the one we just built, which is this. This is the program. Yeah. And inside the program, we what we want to do is to call the method to we want to access the methods. So program methods. And then which method do we want to access? Hello. So which is this. You get? So hello is not taking in anything, no argument, you're not passing anything. So when we call hello, we call instruction. So hello is a function. So by calling instruction, we convert it to an instruction. So next thing we do, so what we have here is an instruction. So what we do next is the transaction we created earlier, we add an instruction to it. Yeah. And then next thing we do is to send this transaction to the Solana blockchain. So what we do is Web3 dot send and confirm transaction. So what this does is it sends the transaction, wait and confirm the transaction. Because it's a very fast process, we can actually afford to wait and confirm the transaction. On the earliest chains like B- BTC them and Ethereum, it's a different function you use to call to send transaction. It's a different function you use to confirm the transaction. But with newer chains and platforms like Solana, you can easily send and wait to see the transaction is confirmed, and you know it's the confirmation takes just a few seconds, less than a second actually. So when you get the transaction hash, we print it here. So the transaction hash is what we use to track this transaction we just executed. Seems someone dropped the comments. Let me check. Said is my screen is it still blurry? Hello? Oh good. Is my skin my I say skin, sorry. Is my screen still blurry? So, I'll just continue. So when you print this transaction, you see this transaction hash. You can track it on Solana Explorer and see what's involved in the transaction. So to go over this again, let me execute this transaction. So when we run this command, this is what we get. This. So if we take this, yeah, this transaction hash, take it to soul scan, we take soul scan. On SourceScan, we have the option of running on the Solana mainnet, testnet, or DevNet. Remember, we've been working on DevNet since. So you select DevNet, paste the transaction hash, click, and then we see the transaction. This is it. It was executed 1 minute ago. So the fee cost was this amount of so. This is very insignificant. And then you can see if you want to inspect further to see the transaction details. So what we interacted with is this program. So if we go here, you see BGCP. You see it's BGCP. That's the program. And then when you open here better, you see the program logs what it logs. That's this message we printed. Message hello world. We print the word hello world. So let's say we've deployed this program and now we can interact with it. Let's say we want to update our program. It's very simple. It's the same process we did last time. You just update, you just change whatever you want to change in your code, and then you update it, and then you deploy it again. Um, okay. So let's just try. I'm just going to type my full name. Yeah. Deploy this. Build first. Build successful. I have some warning, but it's not relevant. To clear the warning, I could put an underscore in front of the CTX build again. This variable. With underscore. I believe I just did what they wanted me to do. I don't know why I'm still having the same error. Let me try one more time. Oh, sorry. I was I was actually checking previous build, so you could see build successful, no more warnings. So after building, since we have deployed earlier, we can upgrade our program by just pressing this button, which is the same thing as deploying again. So upgrade to deploying, and if we have enough so in here, we should be able to deploy. So deploy successful. So this time around, if we call our program, guess what? Um, no, this is not what I want. How do you want? Yeah. So to run this program again, by the time we run this program again, running client side, we get this hash. So we take this hash. It's different from the previous hash. Copy it, take it here. Remember, we're working on DevNet. Paste it here, click. And then this time around, my name is being printed on from the program. So that's what it takes to just update your program. Very simple. But if in a situation where you want the program to not change, you want it to be the same thing, what you're doing when you're deploying is anchor deploy. You do this final. Yes. So since we don't intend to stop updating this program, we won't be executing this. But this is what it takes to make your program permanent, to avoid updates, future updates. So that's about it for the Hello World program. So what I want to show you guys today is how to execute this on your local machine. Yeah, this is a playground where things are made somewhat easy. So from here, you could tell from this client side, you could see we're using PG. PG just abstract a lot of things for us. So what we're going to do now is to execute this with on our local from my local machine. So you'll see the somewhat difference. What we're doing is actually a simple task. I'll deploy it on my local machine and then deploy it on DevNet so we see the difference. So let's go. Let's start now. What we're doing is let me switch to a counter PDA. So this is what we'll be using for this current class. So I don't need to zoom this that much. So I'll be using this for reference, and then let's start. So so are you guys with me? Sometimes it feels like I'm just speaking to myself. Somebody should say something. Are you guys with me?
Yeah, we are together.
Yes.
Okay.
Yeah.
So okay.
But
Okay.
before we proceed,
Yeah.
um, Uncle, I just want to the extensions. I saw at the top left. It looks like I saw
Extension.
extension. Yeah. So those extensions, I don't know the meaning of. I mean the full meaning.
Which extension? Sorry.
You know, here we have a library extension RS, and then the client aspect. You know,
Okay.
you open two tabs.
Okay. The extension. This is the extension for Rust. Yeah.
Okay. So RS is first. Okay.
Yeah. So if you're writing a Rust program, it's RS. So for
Okay.
this earlier one, we had to this TS for the popular TypeScript. Yeah.
Okay.
So that is
Okay.
it.
Okay. That's
Yeah.
fine. I'm okay.
Okay. So so let's let's go back to um I want to create a new program now. Um on this we're going to name um this program, we're going to name it counter. I believe that's what it is here. We'll be making use of this counter program to show you guys what it means to build on your local machine. But can you guys see my screen? Is it blurry despite being small? Is it blurry?
Yes.
Yes, it is. Perhaps it's because the background is black and then the text is not white.
Okay. So I'll just try to say out loud what I'm typing to make it somewhat convenient for everybody. Let me see if I can increase the size of my screen. Um, Let me see. Uh, I can't remember where this is done. Very sorry, I don't know how to go about this. We might just have to manage this. We may just have to manage this, and then I'll try to mention to spell out to say out what I'm doing. So what we're trying to do now is to create an anchor project. If you remember, I said Anchor is built on top of Rust to make Rust somewhat easy for us to work with on Solana. So what I'm going to do now is to create a project on our counter project using Anchor. So to do that, you type Anchor if you have Anchor installed on your PC. So to check if you have Anchor installed, you just type Anchor double dash then version. So doing that, you see the Anchor you have installed on your PC. So you type So to create our project, you do anchor in it. Then the name of our project is counter. So when you do this, Anchor takes some time to generate the necessary files you need to start developing. So this is going to take a while. So let's just be patient. But can you guys see my screen? Can you guys see what's happening?
Yeah, yeah, we can see what's
So,
loading.
yes, can see it.
Okay. Is anybody attending this call with a phone, or is everybody using a PC?
I'm using my phone.
Okay. If yeah, eh? Using phone is PC. Okay. Chukwuebuka and Oluwafemi, you don't have a PC. If you have, it's always better to like use a PC so you can always see these things you're doing. Please, in case of next time, just try and use a PC. Using phone, you're programming. This is not like a writing class or something like a motivational speaking class. This program, this is a technical class. So things like this needs we need to like interact with machine, and I need to do some stuff, so you guys need to see my screen properly. Okay, 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 I understand. So I'm just going to try my best to explain. So this actually takes some time. It's going to download some dependencies we need, and then connect the whole thing, so it makes things a little somewhat easy. So we could use Visual Studio Code, or we could use Rust. So I prefer using Rust Rover by IntelliJ. So I'm just going to open this project I just created. So to do that, say open work tutorial counter. So this is the project. I'm going to open it. Trust project. Like I said earlier, VS Code is actually a good option if you are having difficulty using Rust Rover. Plus, Rust Rover over time will be paid for, and VS Code is free always. So, so with Anchor, you could see these are external libraries. Basically nothing here at the moment. Um, So I'm going to show you guys where the whole code happens. This lib.rs, that's library.rust. So all our dependency and setup goes into this section, cargo and X cargo. Mainly this cargo.toml, and then our library. This where all our code gets will be written. So after writing our code, the next thing we'll do is to test it inside here. So that's what we'll be doing next. This time around, we'll be testing our code. So why this is indexing, we're done indexing. So the next thing is to first thing I want to do is to try and build this project. It's an empty project, so it's supposed to build. So I'm going to write anchor build. So with anchor build, it's check if there's anything that needs to be installed and try and install it before. Yeah. So it takes time. So, while that is happening, this is what we need to build our counter. One thing that is different here that we never did is to use PDAs. PDA is program derived accounts. These are accounts that is used by the program to store data. So anytime you need to retrieve data, you retrieve it from that account, or to update data, you update it on that account. So by default, Solana programs in itself does not store data. Unlike what you have on on Ethereum using what's it called again, Solidity, you can store data in a smart contract. But in Solana, you don't store directly on your smart contract. You store it in an account that is owned by the smart contract, in our case program. So with time you're going to see um, what a PDA is. I believe I have a question or so. Abu, you can ask your question.
Please, I want to find out whether at this point we're supposed to be following you step by step, or we will just observe how you go about things, then later on we will try out.
What? Come again.
I'm asking whether we are supposed to follow you step by step. Like maybe you open here, tell us, okay, we are going for this step, then we follow.
Oh,
Um, Call, then we follow. Or we are just going to observe how you take us through, then later on we will try our hands.
oh, okay. It's better I take you guys through and then you try it later. Yeah, that will be faster since we have very limited time. And this class is here. You can always go over it again. You get. So the best. I wish everybody can follow, but the best format in this case would be for me to write the code, for me to show you guys how to do these things, and then you practice yourself. Okay. So this takes a while. So while this is working, I'll just be building. Anytime it's finished building, we'll build again. So for this counter, yeah, what we want is for everybody to have their own for everybody to be able to count 1 to 1,000 or something on this program. Yeah. So for this for so everybody has their own you can see the authority and the count. So everybody and their own count. So each time you call the program, the count should increase. So if you're using your own account to call the program, this same program, it will count for you. If another person call the program with a different public key, it will have the person will have his or her own counter separate. So let's start. First thing, we need to create a struct that holds the authority and the state of the count. So to do that, we already have something here called initialize. We're going to change this to our counter. So we have our counter. This is stored as account, so derived account, very normal. No, sorry, this is not what we are changing to accounts. We're going to create a struct different. So we create a struct called counter, and then it has authority of pub key, and then the count is unsigned integer of 64. So let's keep it at this, and then we need to make this of type account. Yeah, just to say, okay, this struct is going to be an account that saves states. I don't know why this is failing, but we'll come to this later. Let me see. This is failing. So we always come back to this to know why it's failing. We've not written anything, really written anything, and it's already failing. Targets. Okay. So after creating this account um, that holds our data, the next thing is to call the function. Let's see what the next thing here instead of assuming what the next thing is. So let's see. Next phase is creating our counter. So to create our counter, we need to create our counter. We need to create the create counter function. So this is what it does: create counter. If you have any question, you can always unmute yourself and ask me immediately. So it's a create counter function, and we need a couple of accounts to create this counter. So instead of initialize, we have create counter here. Yeah, and from this example, let's see functions, the accounts we need. We need the authority, that's the person signing the transaction. That is you trying to send the transaction. We need the counter, that is the address that is going to be counting, that we're going to be counting, that's going to be storing the state of the counter. And then system program. Why we need a system program is because this when we are calling this function, this system program is needed to set up our counter. So by default, I'm going to miss this and see what the error we're going to have, because if you just to show you guys how much help Anchor helps you when you miss some things, and it's going to show you to so that you just fix it. So the first thing we need to do is the authority. Authority is going to be signer um, info. We need to enter this info. The next thing is what's it called? The counter. So our counter is of type account info, and it's derived from this counter. So we need to add some comma here. Can you guys see? I don't know. I just have this feeling to always ask if you guys can see what I'm doing. So what we need to put here is an account as expected. Accounts. So when you put this account inside the bracket, you put mute. What that means is that this account called authority, the value in it is going to be, we need, the program wants it to be able to change. So that's what the mute stands for. That is mutability. So authority is supposed to, we want we in what we want is when we're signing this transaction, authority will be debited. So that's the essence of the whole mute thing. So I'm just going to change this to create counter. Yeah. So the next, am I having this error? We're not supposed to have this. Okay. So the next thing is this. The second account we need is this. And this account is a storage account. So we need to initialize it with init. And then the next thing would be set seeds on bump. Seed. Seed will be of type. Seeds will be of this way. It's going to be derived from the authority key. So authority, and we need to access the authority key with key.ref. Yeah. key dot as ref. So that's what we need to set up the seed. The next we need to add bump, and next we need to one more thing. Okay, two payer and the space. Payer means who is going to be paying for the transaction that will be happening in here. So for that, it's going to be this account authority. The next is on space. We're going to set it to 100. So let's try building this again to see what happens. Oh god. You know why this is unstable? Let me see.
So this is local, not online.
Yeah, this is local. Yeah, using unstable library. Let me see. I can't tell why this is. I'm having this error. It seems one of what we're using is. Let me try updating my anchor and see if I'll try updating anchor to see if it be of any good. Not seen this particular error before, so I can't really tell why. Feature it hash as simple hash one. Um, you know what? Instead of taking too much time, we're going to just build this on the playground. Yeah, so that on our next class, I'm just going to do everything on the on local machine, which is a somewhat of a different environment, so that we have a feel of it. This particular error, I can't tell why I'm having it right now, and I don't think this is the right time to start debugging this issue. I don't know if we are cool with that. Hello,
Yeah, we are cool.
are we cool with that?
Yes, yes, we
Since
are.
we,
Okay, I can't speak for everyone, but I am. I only wanted to say something.
okay, okay,
Maybe as we do, then perhaps you suggest to us some YouTube videos that can assist
what?
us with. I'm talking about you assisting us with YouTube videos
Yeah,
that can that's the same way like you are practicing here. Then we'll be following it step by step. So by the next class, we might have followed those resources that you give us,
okay,
practice it, then come up so that you
okay,
not be many steps ahead of us.
okay. That's a good suggestion. I'll do that. I'll send some videos across to help with that. Okay. Victoria, please just remind me so I don't forget. I'll do that maybe by tomorrow. So so since you're using this you're back to playground. I'll be explaining what is here. So like I said yesterday, this CTX context holds all the accounts, like all the public key we are going to be using to interact with with this instruction. This instruction, what you're trying to do here is basically initialize, like to create this counter for each person. Anybody that wants to call the program will create a counter for the person. Another person wants to create a program will create another person calls the program will create the counter separately for the person. So what you're doing is this. Um, so to create the counter, we're going to be using the CTX. Like this instruction says, the creation of the counter must be here. So let's implement it. So we initialize the counter, and then from the counter, we to get access to the counter is from the context. The context a couple of holds all the accounts we need to interact with this instruction, and then from there you have authority, counter, both authority and counter, and then system program. Those are the three accounts here: authority, counter, and system program. What we need access to is the counter. So we say counter. Now we've gotten the counter. You end with a semicolon. So what we want to do next is to set the authority and then set the counter to 0 as a start. So say counter dot count. Set it to 0, and then counter dot authority. That's the person. We are setting it to the person who is signing this transaction. That's the person calling the program. So we say ctx dot account dot authority. So to get the public key, we say key. It's a function. So by doing this, we've set we've done the first step, which is to create the account for any individual who wants to interact with our program. So let's build. What I normally do anytime I work on Solana is that when I write some code, I try to build to see if I'm having any error and fix it immediately. So we're going to do that here and call build. When we build this, that's when the ID will come out here. So argument build wasn't expected or isn't a valid context. Anchor works a little different here, so I'm just going to use the default the button here. But normally you just type anchor build and it builds your program. So let's just use this. So once you type build, it fills in the program ID here. So use the path separator to refer to an item. So let's continue. So we have create account. Let me just check for question. So we've done the first phase, which is to create account. So the next one is data validator. So I've explained this part already earlier, which is the counter thing. So what happens here? Let me go over it again. So when creating the counter, which is a PDA, a program derived account, this is what happens. We set the program derived account to be of type this counter, which holds public key and count. You get? So we initialize it and then we set the seed. The seed is what is used to derive the address of this PDA. You remember I said this is an account and every account has an address. So what is used to derive this PDA is the signer, this authority, the authority's key, which is basically the authority's public key. So bump is usually is also an added feature when creating this account. Over time, we get to understand these things better, but this layman definition should stick better. So the next we have payer. The payer is the one person that's going to be paying for the storage of or the is going to be paying the rent of this account. I'm sure you guys remember what rent is. So when creating any account, whether it's a PDA, a normal wallet account, um, you need someone to pay for the rent. So that's where this payer comes in. And the space, we need to define the amount of space we want to give our account. For now, we're just going to hard code it to 100. So so we can move forward. Let me just explain. Signer, I explained this earlier, person who is going to be signing this transaction. So the next, which is the last command, is to update our counter. To when someone calls this the counter function, we want to add one to it. Add one to it. So it's very simple. All we just need to do is get access to the counter, just like we did earlier. ctx.account.counter, and then guess, you don't need to guess what. It's very simple. What you just need to do is this dot count, and you do this plus one. Is this simple? Is this clear? I need you guys to speak up once in a while. Is what I'm doing understandable? Nash, are you following?
At the moment,
Yeah.
I'm following. I can't say I fully understand. I
You're
hope to practice it later after this one.
okay. Okay. Chukwebuka, you understand?
Okay, I'm just dragging you guys, but then I know that when I come back to it, I listen.
Okay. So I should keep on going. Is
Yes.
there
So
anything you
what
want me
I
to revisit?
so what I understand is that like my knowledge in Excel and then SQL, that's SQL. I know
Yeah.
there are arguments when you are trying to program something.
Yeah.
So I say the same way, like teach it to understand what you want to do, so that when you execute it, the results displays as you want it. If it doesn't, then you go back and visit it. That is how I understand it, and that's how I know it is very simple for me if
Yeah.
I try to practice it after the class.
Okay. Okay. No problem. So I'll just continue. So you've basically done everything that's required to create a counter. This is basically it. At this point, I don't think we need anything else. Um, okay, I just need to explain update counter, the values inside update counter account. This for creating counter, and this to update counter. So as usual, there's always a need for a signer, which is the authority. Sometimes I just name this payer, but using authority sounds better here. And then the counter. You remember this counter, we we already initialized it earlier the first time when we were creating the account. So we don't need to initialize it anymore. But we need it to be mutable. You get? And we need the authority to be of this. That's what has one stands for. I don't know why it's named this way, but if you want to restrict the we want to make sure that the account you're calling is from is controlled by this. We use the has one what's it called, counter. The has one feature. So we'll be going next to the next stage. I guess we should be to build and to deploy. So we build this. It should build properly. Yeah. I think there's any error. Let me clear this and build again just to be sure we don't have too much warning. Consider borrowing here. Okay, there's always suggestion when working with Rust. So here it's saying there's a borrow feature, and I should use ampersand. Let's try it. Try their suggestion. Let's see what it brings. Let me see. I don't know why anchor build does not work. Okay, let's try building again. Now, let's just revert back to what we had earlier. So I'm just going to build and then deploy. So it works, then we deploy it. Having an error. This is unusual. So let me try building again. Cannot move out counter, which is beyond immutable reference. Okay, let me see why we are having this. So uh, I just want to see if I'm missing anything. Error counter dot authority has counter is not declared as mutable. It's not declared as mutable. Is this something I'm missing? Just pardon me. I just think I'm missing something. Oh. Just needed to put this because I need to borrow this value as mutable. Sometimes I'm not going to lie, I'm not very perfect with this Rust system, so sometimes I forget about these rules around borrowing values. That's where the whole mute thing is. Because this value is stored on the way the value is stored, I need to borrow it as a mutable value before updating it. So with this should work now. It should work without errors. Yeah, build successful, and I'm going to deploy it. Oh, I have an error because I don't have enough so what I'm going to try and do now is to airdrop myself more so what I'm going to do is to get my address first. Solana address. We're already late. I'm already past 8 p.m. This class was to end by 8, but let's just keep going. I'm almost done. So I'm going to airdrop myself some tokens. Solana airdrop. Airdrop is maxed at 2 a day. So I'm going to airdrop myself, requesting airdrop 2. I should get it. So I don't know if this is enough to deploy. Let me try again. Oh, I need a little more. Let me try if airdrop feature is going to work. I've requested beyond normal request. So what I'm just going to do is, yo, you got through. So don't worry. I'm just going to use Solana faucet. Faucet is where you can get DevNet Solana for free. So Solana faucet DevNet faucets. With testnet you can drop as many as you can, but on DevNet you're limited to just 2 a day. So I'm going to pick 2.5. Confirm airdrop. Just going to try and validate me. Airdrop success. So Now I should be able to deploy. Okay, to deploy, I don't even need to type anchor. I just need to type deploy. That's interesting. So deploying. Okay, deploy successful. So now you've deployed. Next thing we want to do is to try and call our program. Let's test it first. So how do we test this? So the authority will be our public key. Random create current wallet. So we use current wallet. Yeah. Counter would be um this is a bit confusing. Random current. We can't use random. We can't use current from seed. No. Or program. Let's see accounts. Wow. No, this is not what I want. Account needs to be um a derived account, a PDA. Let me see from seed string. Let's try this. So because it's derived from, yeah, I think this is what we want. Yeah. So random seeds one, and then program this. So let's generate it. Yeah, this is what I need to do. This is strange. Um, from public key, current wallet. Okay, we've generated the right PDA that is derived from the public key and the program ID. So we're going to test this and see if the test passed. So creating counter passed. So let's try updating. So what we need it to pass the authority as usual as the current wallet, and the counter is going to come from seed passing public key, and the public key is coming from the current wallet. So we generate this and test it. So test successful. What I would like to do right now would have been to test it with just the way we did with our previous our previous class, but I'll be skipping that today because we already passed time. So what I just did here was to create count update it. So if you have the time, what I will encourage everybody to do is to try to come to this tutorial, to this example, create counter, update it, and then reduce it. More like instead of using update, use increase counter and decrease counter. Give it a shot. Hit me up on Twitter if you have any issues. I'll help you out with it. Next class, we're going to go through it together and then call it from our local machine instead of the whole example we have here. So try and give it a shot, and then our next class, we're going to implement the whole thing with maybe a React app or something, small React app, and let's see how that goes. Is there any question? Any question concerning PDA, the storage system we're using to store the counter? Any question about that? I will say something, Olufemi, if you have any question or anything else, we'll call this a day.
Yes. Uh, Thank you very much.
Okay,
At the moment, I don't have any question. Um, I'm
okay,
excited to be live, and this night I promise to sit, practice it, and update you like I always do on your Twitter. Then we
okay, okay. Ibuka, you can ask any question actually.
All right, thank you.
Um, you're on mute. Any question? I think we'll call this a day. So try and create account, increase the count, decrease the count. I want to hear from you guys. Let me know what you guys are doing. And our next class, we're going to implement the assignment I gave you. And we're going to implement the assignment, and then we'll call it from a React app. At least that will give us a good understanding what it means to have these programs, um, how to interact with a blockchain program that is on the testnet. I think that's all for today.
yes, yes. Before you
Um,
I have a question.
okay,
Between Anchor, Rust, and then the other
so
elements, I don't know what to mention. So
Solana.
do they have different method of arguing out your programs, or they're all the same? But when you feel like you want to use Anchor to build it, or to use Rust to build it.
Okay. This how it works. Yeah. We have Solana, which is the blockchain. Yeah.
Okay.
So when you are executing some instructions on your command lines, things like airdrop, things like check balance, use the Solana command itself. Yeah. And then we have Anchor. Anchor helps you to manage building, testing your program, deployment. So that's where you see things like Anchor build, Anchor deploy, which I was trying to use earlier. So so that's what Anchor does. Anchor is not a language. Anchor is a framework. Now, Anchor is built on top of Rust. Rust itself is the language. So Solana is not a language. Anchor is not a language. Rust is the language. So Rust is everything we've been doing so far here. All the code you're saying is basically Rust. You get. So Anchor is just a framework that is built on top of it to make it easier. It's just like if you know React that is built on top of JavaScript to make web development easy, something like that. That's what Anchor is.
Okay. Then
Um, no more questions. So roll call for today is Abonash, Oluwafemi, Chukwebuka Obi, Senchi. This Sinki or what? Can you pronounce the name so I don't get confused?
I wonder. I'm yet to find out who the participant is, so that later on I can be writing the names very well.
Okay, and then we'll have one guest. I think that's all for today. Um, on Wednesday, I promised to fix the bug I was having earlier, and then we will do something more practical than what we just did just now. Is that fair with you guys? I guess that's all. So Victoria, I think you can take off from here. We'll call it a day.
Okay. It's Kelsey. The guest was actually
Okay,
Kelsey.
Kelsey.
I didn't edit my
Okay.
name.
Okay.
Yeah. Okay. Yeah. Thank you, okay, coach.
Okay.
Uh,
You know,
yeah.
take care.
Okay. Yeah. So I'm sure we've. All right. All right, guys. Bye, guys. See you guys next week.
Bye.
Bye.